Welcome to the Super Memory for Schools program. My name is Pham Thi Kim Ngap. Today, I introduce to you the lesson, Memorable Identities. In this content, you will learn about the first three memorable identities that are the square of a sum, the square of a difference, the difference of two squares, and the content of the note. Let's get into part 1, the square of a sum. There is a math as follows. Please calculate a plus b squared. The answer of a plus b squared is the product of two polynomials, a plus b times a plus b. Please start multiplying polynomials with polynomials. From there, you deduce a formula as follows. With a, b being arbitrary expressions, we have a plus b squared equals a squared plus 2ab plus b squared. Now, we get into applying identity number 1. The math is as follows. Question A. Calculate a plus 1 squared. Question B. Write the expression x squared plus 4x plus 4 under the form of the square of a sum. Question C. Calculate quickly 51 squared, 301 squared. The solution is as follows. Question A plus 1 squared equals a squared plus 2 times a times 1 plus 1 squared. And we get the answer, a squared plus 2a plus 1. Question B. Write the expression x squared plus 4x plus 4 under the form of the square of a sum. And x squared plus 4x plus 4 I expand as follows. X squared plus 2 times x times 2 plus 2 squared. So according to the identity number 1, it equals x plus 2 squared. Question C. 51 squared. 51 equals 50 plus 1. So 51 squared means 50 plus 1 squared. Then you expand the identity number 1, meaning 50 squared plus 2 times 50 times 1 plus 1 squared. And the answer is 2601. The second point of question C, 301 squared equals 300 plus 1 times squared. You also expand the identity number 1 equal 300 squared plus 2 times 300 times 1 plus 1 squared. And the answer is 90,601. Now we come to the identity number 2. That is the square of a difference. The exercise is as follows. A plus negative b squared. Here, a, b are the arbitrary numbers. The solution is as follows. Applying the identity number 1, we have a plus negative b squared equals a squared plus 2 times a times negative b plus negative b squared. And you will get a squared minus 2ab plus b squared. From there, you conclude a minus b squared equals a squared minus 2ab plus b squared. Therefore, with two arbitrary expressions a, b, we also have a minus b squared equals a squared minus 2ab plus b squared. Now we get into the application exercise section. The application exercises are as follows. Question A. Calculate x minus 1/2 squared. Question B. Calculate 2x minus 3y squared. Question C. Calculate quickly 99 squared. The solution is as follows. Question A. X minus 1/2 squared equals x squared minus 2 times x times 1/2 plus 1/2 squared. And the answer will be x squared minus x plus 1/4. Question B. 2x minus 3y squared equals 2x squared minus 2 times 2x times 3y plus 3y squared. And the answer will be 4x squared minus 12xy plus 9y squared. Question C. 99 equals 100 minus 1. So 99 squared equals 100 minus 1 squared. Then you expand the identity number 2. Meaning, you will get 100 squared minus 2 times 100 times 1 plus 1 squared. And the answer is 9,801. We move to the identity number 3, that is the difference of two squares. Do the calculation a polynomial a plus b times a minus b, with ab being arbitrary numbers. The solution is as follows. We multiply two polynomials, a plus b times a minus b equals a squared minus ab plus ab minus b squared. And we simplify minus ab plus ab, so the result here is a squared minus b squared. Therefore, you can deduce a squared minus b squared is the product of two polynomials, a plus b times a minus b. With two arbitrary expressions, a and b, we also have a squared minus b squared equals a plus b times a minus b. We go into the application exercise. Question A. Calculate x plus 1 times x minus 1. Question B. Calculate x minus 2y times x plus 2y. Question C. Calculate quickly 56 times 64. The solution is as follows. X plus 1 times x minus 1 equals x squared minus 1 squared equals x squared minus 1. Question B. X minus 2y times x plus 2y equals x squared minus 2y squared, meaning it equals x squared minus 4y squared. Question C. 56 times 64. Here we separate 56 equals 60 minus 4. 64 equals 60 plus 4. So we get the answer, 60 squared minus 4 squared, and it equals 3,584. There is an exercise as follows. Who is right? Who is wrong? Duke writes x squared minus 10x plus 25 equals x minus 5 squared. Tho writes x squared minus 10x plus 25 equals 5 minus x squared. Hung comments as follows. Tho writes it wrong. Duke writes it right. While Son says, through the above example, we can deduce a really beautiful identity. What's your opinion? And according to Son, what identity will deduce? Now let's come to the solution. X squared minus 10x plus 25 equals x squared minus 2 times x times 5 plus 5 squared. So it will equal x minus 5 squared. Besides, x squared minus 10x plus 25 we can acknowledge as follows. 25 minus 10x plus x squared. And according to the identity number 2, it equals 5 squared minus 2 times 5 times x plus x squared and equals 5 minus x squared. So Hung's opinion is incorrect. Both Duke and Tho write it right. And through this exercise, we can deduce a really beautiful identity, that is, with a, b being two arbitrary expressions, we also have a minus b squared equals b minus a squared. So this is my note. A minus b squared equals b minus a squared. I will summarize the content of the lesson for you. In the memorable identity of this lesson, you need to remember three identities for me. That is the square of a sum. A plus b squared equals a squared plus 2ab plus b squared. The identity number 2 is the square of a difference. A minus b squared equals a squared minus 2ab plus b squared. The identity number 3 is the difference of two squares. A squared minus b squared is the product of two polynomials, a plus b times a minus b. And the note, a minus b squared equals b minus a squared. Our lesson ends here. Thank you for your attention and listening. See you in the Super Memory for Schools program next time.